Okay, so simplify and use absolute value signs. It is assisting, but here signs when necessary. Oh crap, I'm not touching. All right. So once again, simplify and use absolute value signs when necessary. So in the first one, you'll see something like this level, pretty easy. You'll break it down, 7 times 7, and then we'll pull out groups of 2 because it's the square root. So 7, and then remember that you can just think of this. Now, if you needed to write out 10 x's to get it right, I mean, who cares? Get it right. But once again, we're saying how many groups of 2 are there in 10? 10 divided by 2 is 5. So x to the 5th. So that one's going to come out pretty easy. So then you'd say to yourself, do I need absolute values? Remember, you only need them if it's an even root. So square root, yes. And then odd exponent in your answer, you'd say yes. So you'd add in absolute values if necessary. All right, so make sure you don't add absolute values around the whole number part. Okay, number 2 will be something of this level. So once again, simplify and use absolute value signs when necessary. So we have the square root of 10 times the square root of 15. So we would just write it, since they're both square roots, I'm just going to go like this, square root of 10 times 15. Now you could actually multiply them together and then break it down, but I'm not going to actually multiply it together. I'm just going to break it down right here. So 10 breaks down into 5 and 2. Okay, 10 breaks down into 5 and 2, 15 breaks down into 5 and 3. Nothing more breaks down, so we're pulling out groups of 2 since it's a square root. So we pull out a 5. Don't do 25 on accident. Don't miss the easy ones. So we pull out a 5, right? And left would be 2 times 3, which is 6. So 5 squared is 6. Now there's no variable, so you wouldn't need absolute values in this example. Okay, now there'll be a division one. Take my suggestion, anytime you're dividing 2 radicals, put them together, divide everything you can, and then you can split it back up if you need. So they're both under a cube root, so let's put it all under the same radical. Cube root of 18 is on top. That's it. We have a 9xy squared. So then what I would do is say, okay, does anything simplify here? 18 and 9 do. That would become a 1, correct? And a 2. And then if there was more variables, you'd divide those out, but there's not here. So then now you'll say, okay, now I'm going to re-split it back apart. So on top, I have, make sure you write cube root, not square root on accident. Cube root of 2. On bottom, I have the cube root of xy squared. Now what you should be doing is looking at the top and saying, can I pull out any groups of 3? Nope. What about bottom? Nope. So then you would rationalize the denominator, but you would only do that last. Nothing simplified, so now we'll rationalize. It's a cube root. So for a cube root, just a reminder, you need something to the 3rd power. So we have the cube root of, we have 1x. How many more x's do we need? 2 more, correct? X. And then we have y squared, so we only need 1 more y, right? If you do this for bottom, you've got to do it to the top. So now you'll say, okay, now I'm just multiplying straight across. So since these are both under a cube root, they'll go under the same house. 2 times x times x times y. That's the cube root of 2x squared y, right, everybody? And nothing simplified. Look back before you even multiply it. There wasn't 3 2's, there wasn't 3 x's, there wasn't 3 y's. So that's why we know the top doesn't simplify. On bottom, I don't know why this part throws people off so much. You're multiplying straight across. Oh, yeah, so x times x is x cubed, correct? So I'm going to do it down here. We have the cube root of x times x times x. Isn't that x cubed? Y squared times y is y cubed. So now cube root and cubed cancels out. So left on bottom is just xy. Then you would say, well, that's it, because nothing more simplifies. So be really smart and don't mess that one up, because that one's really not that difficult. Questions on any of that? Okay. Oh, we better check. This is in the section of Simplify and use absolute values when necessary. So cube root, is it an even root? No, so we don't need absolute values. If it was a square root though, let's change and let's say that this was a square root. Wouldn't these both need absolute values? Okay, good. Okay, so fill in that same section is simplify and use absolute value signs when necessary. So in this one, we're multiplying two square roots, so let's put it all under one square root. I'm going to reorder it, 45 times 36. Once again, you could actually multiply that out or just leave them apart because we're going to break them down anyways. X to the fifth times x, and I'm going to cross them out so I don't miss anything. X to the fifth and x squared would be x to the seventh, right? When you multiply, you add. Well, and then we have y to the seventh, y to the fourth, so 7, 8, 9, 10, 11, so we have y to the 11th. Now I'm going to break down 45, 9 times 5, right? 36 is 6 times 6. 9 breaks down into 3 times 3. And I'm just going to break these down because a lot of people, if they don't, they miss things that they shouldn't. Don't double dip. 9's not there, 6 isn't there, 6 isn't there. Okay, we're pulling out groups of 2. So we'll pull out a 3. We'll pull out another 3. We'll pull out a 2. 3 times 3 is 9. 9 times 2, 18. So we'll have an 18 on the outside. Left was a 5. So I'm going to give myself some room, put the square root over here. We have a 5 underneath. X to the 7th. So you would say you could write out 7 x's and circle groups of 2 if you were desperate. But if you're an advanced thinker, won't x to the 6th divide evenly? X to the 6th. So you would do 6 divided by 2 is 3. So that was x cubed on the outside. And then if that was x to the 6th, how many x's was left underneath? 1x. Does everybody see? But if you were desperate, you could write out 7 x's and pull out groups of 2. And then y to the 11th, I'm going to think of y to the 10th because 10 divided by 2, right? 10 divided by 2 is 5, correct? So we have y to the 5th on the outside, and then that was y to the 10th though, so how many was left underneath? 1 y, correct? So once again, if you were desperate, write out 11 y's and circle groups of 2 because it's better to get it right than not. You know what I mean? Okay, but hopefully you're able to think of it like that. Questions on that level? Oh, let's add absolute value signs. We're not going to ignore we're going to have to keep reminding ourselves when we take the test to read the instructions. So let's add absolute value signs when needed. Even root, yes. Odd exponent, correct? So we would add absolute values around both of those. Don't forget the absolute values because that's worth points. Okay. Number 5, simplify and use absolute value signs when necessary. So there's a lot at this level. So we're dividing this. So wouldn't it be smart to actually divide everything out that we can? Okay, so let's focus on underneath. 162 divided by 2 is 81, I think. So that becomes an 81 on top. Make sure you write it in the correct spot. A lot of you are really bad at not writing it in the correct spot. That's 81, that's 1. And then x to the 5th and x cubed would be x squared on top, correct? So I'm looking at this. Square root of, that became a 1, that became x squared. So I'm really just looking at the square root of 81x squared at this point, correct? Now what's the square root of 81? 9. The square root of x squared, x, we're pointing out a group of 2. So it won't just be x, don't do x squared, right? Okay, let's add absolute value signs when needed. Even root, yep. Odd exponent, yep. Question. Okay. All right, now there's going to be random places on the test where I ask you similar to the way I'm wording it here. I'm not wording it exactly the same. So if you pay attention, you should get the idea here. So it says true or false. When solving the equation x squared equals 64, you get plus or minus 8. Is that a true or false statement? True, right? You have to put plus or minus because remember what we're talking about is what squared equals 64. When you solve for x using algebra, you're literally just finding the x value that will make this a true statement. So positive 8 squared works and negative 8 squared works. So this would be a true statement. Okay, the next one. When simplifying the expression, the square root of 64, you get plus or minus 8. Now this one's almost like a trick question because it depends on the wording, correct? If I said, do you find all the roots? You would need plus and minus. If I said simplify, you only go with the primary root, which is 8. So does everybody understand the difference in that one? If I say simplify, the answer is 8. If I say find all the real roots, you need plus and minus 8. Okay, so just remember the difference between those two. Okay. All right, so I'm going to scroll up because there's some people in the back. Looking at this next statement, it says, is this true or false? Unless B is a negative number, our answer will be imaginary. True, correct? If we have 2 times, and you can test it out, 2 times negative 3, and then let's say B was positive, times 2. That's 2 and then square root of negative 6. Won't that be an I? Okay, so let's test our other theory. Let's say B was negative. That's 2 times the square root of negative 3 times negative 1, for example. Well, that's 2 square roots of 3. That's not imaginary, correct? So that one would be a true statement. Everybody good with that? Okay. All right, simplify. So we're going to simplify. So we're on to the next section here, simplify. We don't need absolute values. In the instructions, it doesn't say anything about absolute values. So you would say, okay, we've got to be able to add radicals if possible, but we don't know if they're like radicals unless we have them in their simplified form here. 9 times 3, 3 times 3, point out groups of 2. Now, don't get careless and start zoning out on the test and miss little things. This is 5 times 3 on the outside, right? So that's 15 square roots of 3. Does everybody see why? This is 4 times 3. 4 breaks down into 2 times 2. And then don't forget, there's a negative 2 out there. You've got to pay attention. So that's negative 4 square roots of 3. Now, are they like radicals? Square root 3, square root 3. So yes, they have to be the exact same here and here. Root and base. 15 minus 4, 15 apples minus 4 apples is 11 apples, correct? So 11 square roots of 3. Pretty easy, right? Okay. Simplify. So once again, you don't know if they're like radicals unless you break it down. So 8 breaks down into 4 and 2, 4 breaks down into 2 and 2. Don't miss these ones, they're easy if you pay attention. There's a negative 2 on the outside. We're pulling out a 2, not a 4, correct? We're taking the square root of 4, which is 2. Anyways, we're pulling out a 2, so that's negative 4 square roots of 2 and x. Then 18, 9 and 2, 3 and 3, paying attention to the outside. We'll pull out a 3. Do not add them, you always multiply. So 3 times 3 is negative 9. Square roots of 2x. Because 2 is left, x is left. 50 is 5 and 10. 10 breaks down into 5 and 2. We're paying attention to the outside. Positive 4 times 5 is positive 20. Square roots of 2 and x. Now let's combine like terms. So we have negative 4 minus 9, correct? 13, negative 13 plus 20 is 7. And it's positive 7, 2x. Square roots of 2x, sorry. 7 square roots of 2x, because they're all like radicals. We don't need absolute values because it didn't say to do that in the instructions. Don't miss those. Those are the easy ones. Okay, in this section of simplifying, it's at this level. So with this, there's 2 terms. Terms are separated by plus or minus signs, multiplied to 2 terms. We need to double distribute very carefully. No need to miss easy problems from algebra mistakes. So square root of 2 times square root of 5 is square root of 10, correct? Now what I see people do is draw in their arrows all at once, and that defeats the purpose of drawing those in. I do that so I don't miss anything. So draw them in as you go. Now square root of 2 times negative square root of 2. Watch your signs. People mess up on the signs and it makes your whole problem wrong. Positive square root of 2 times negative square root of 2 is negative square root of 4. Now I've taken care of 2, so I'm going to cross it out. Now I'm going to distribute negative square root of 5. Negative square root of 5 times positive square root of 5 is negative square root of 25. Negative square root of 5 times negative square root of 2, a negative times a negative, it's worth it to go slow and think and use your brain, is positive square root of 10, correct, everybody? Okay, let's combine like terms. So in this example, did I make any errors anywhere? Are we sure? Okay, sweet. So let's combine like terms. In this example, our square root of 10s happen to not cancel out, correct? Square root of 10 plus square root of 10 is how many square roots of 10? So 2 square roots of 10. Now you would check, does square root of 10 break down? 5 and 2? Nope, so we're done. Then we have negative square root of 4, which is not the square root of 2. What is negative square root of 4? Yep, negative 2, right? And then we have minus 5. Negative 2, use your brains, don't just write down 3 because 2 and a 5. Negative 2 minus 5 is negative 7. Really, the more proper way to write it would be to write it like this. Negative 7 plus 2 square roots of 10. But whatever, I'll accept either answer. Okay, questions on that? If those were conjugates, if they would have been conjugates, what if I would have changed this to plus, which is I think what I meant to do, wouldn't our middle term have canceled out? Yeah. Okay, so just be watching for that, right, everybody? You get what I'm saying? I think I meant to make that plus. So anyways, oh well. All right, so simplify. So we are going to double distribute again. Now I want you to notice something about this problem. Square root of 16. Shouldn't I just write it as 4 right now before I even distribute? Probably it's going to be easier because you're going to have to do that in the end. So I'm going to rewrite the problem. 2 plus the square root of 3 times 4 minus 4. Well, that's 2 plus the square root of 3 times 0. What's 0 times anything? 0. Okay. Now I'm going to change my problem. That's right. Let's change the problem because I don't think I thought about that very well when I wrote it up there. Let's do this instead. Make it square root of 64. All right. So now don't we have 4 minus 8, which is negative 4? Okay, negative 4 times both of those things. You know what I see people do? They don't distribute it twice. Gotta go to both of those, right? Negative 4 times 2 is negative 8. Negative 4 times the square root of 3 is negative 4 square root of 3. All right. Questions on that? So pay attention to little things like that. Look for radicals that simplify and whatnot. Questions on that? Okay. Now we're to the part where you're rationalizing denominators. All right, so rationalize the denominators. First of all, look at your radicals. Do any of them simplify? No. Now, why are we rationalizing the denominator? Because we cannot have a radical in the bottom. So how do we fix the square root of 7? Multiply by the square root of 7 over the square root of 7. Now, I cannot stress this enough. I have 2 terms right there. If you ever have 2 terms, you need to put parentheses around them. Everybody understand? Now, what am I going to do? Distribute, because it's square root of 7 times the whole top, correct? Not just a piece of the top. Everybody agree? Square root of 7 times 2 is 2 square roots of 7. Square root of 7 times negative square root of 3 is negative square root of 21. Then you'd say, do either of those simplify? 7 times 3, so no. Okay, then we're good. Can I combine those? No, they're not like terms. On bottom, we have the square root of 49, correct? 7 times 7 is 49, right? What's the square root of 49? 7. Now, you would never divide anything out unless all 3 things divide, you know what I mean? But nothing divides out. You would never divide across as a subtraction sign, would you? Okay. It's like way bad thing. Okay, so that'd be our final answer. What I don't see people do is distribute that through. Makes me mad. Okay, here we go. So looking at this one, notice none of my radicals simplify. That's what I always check for first. Okay, now we've got to rationalize the denominator. I cannot tell you how many of you missed this on the quiz, a take-home quiz, like most of you. There's 2 terms. How do we undo a radical if there's 2 terms? Conjugate. Conjugate means you put a 4 in front, you put a square root of 2 in back. The sign is not the same. It's the opposite. So this will be positive. Everybody good? Now I gotta do that to the top as well. 4 plus the square root of 2. Now I can't stress it enough. If you ever are dealing with two terms, you need to put parentheses. Now let's just go off to the side on our test and say, I'm going to focus on the top for a second, and only the top, but you can't forget about the bottom. So right now I'm focusing on the top. 2 times 4 is 8. 2 times positive square root of 2 is positive 2 square roots of 2. Now I've distributed 2 through. Negative square root of 5 times 4 is negative 4 square roots of 5. Negative square root of 5 times positive 2, negative square root of 10, correct? Now you'll combine like terms. Now looking at this, none of the radicals simplify and there are no like terms, correct? So now I'm going to go off to the side and do a little star and say, okay, now I'm going to focus on the bottom. And now we'll just focus on the bottom, and I'm going to change colors to brown. 4 times 4 is? 16. And then 4 times positive square root of 2 is positive 4 square roots of 2. And then we've taken care of 4. Negative 2 times 4, negative square root of 2 times 4 is negative 4 square roots of 2, correct? And then negative, this is where people mess up, negative square root of 2 times positive square root of 2 is negative square root of 4. So let's simplify the radicals if possible. Nope, nope, and don't those cancel out. So we have 16 minus the square root of 4, right? Which is 16 minus 2, which is 14. So we have the top divided by the bottom, which is 14. Now understand, do you see how 8, 2, 4, but this doesn't have anything, right? We can't divide out anything, even though 14, 8, 2, and negative 4, don't they all divide by 2? Unless this one also divides by 2, you can't divide out of 2. That should be all pieces. Does that make sense, everybody? You would never just divide pieces of it. Everybody good? That'd be our answer. Okay. If your bottom, when you rationalize, still has a radical, you did not rationalize correctly, meaning you didn't multiply by the conjugate. So that should give you a hint. If you end up with a radical still on bottom, you should say, what did I do wrong? Because I was trying to get rid of the radical. Does that make sense, everybody? Okay. Sweet. So the next piece of the test says simplify. You'll see the ones of this level. Now remember, you can rewrite rational exponents as radicals, correct? That's not always the smartest way, though. So on 243 raised to the 1/5 power, you would literally type it into your calculator. If it comes out a decimal, you would need to go back and do it by hand. So I strongly suggest always just doing it by hand. Isn't this the same thing as the 5th root of 243? Right? 5th root of 243 to the 1st power. So then 243 breaks down into, because you will have one, there's a good chance you'll have one with a decimal. Like if it comes out a decimal, you'd have to know to go back and do it by hand. So anyways, give me some factors of 243. It comes out evenly as 3. Okay, but does everybody know how to 9 times 27, 9 breaks down into 3 and 3, 27 breaks down into 9 and 3, and 9 breaks down into 3 and 3. So there was 3 5s, 5 3s. So do you see how it came out evenly? But if it was a decimal, you'd have to go back and do it by hand. Because what if something would have been left over? That's when you would have got a decimal. That would not go back to a fraction. Does everybody get what I'm saying? Okay. So looking at this next example here, we are not multiplying the same base. So let's rewrite it as a radical. Isn't this the cube root of 3 times the cube root of 9 to the 4th power? They're both cube roots, so can't we put them under the same root? Everybody watching. So that's the cube root of 3 times 9 to the 4th. Think of that as the cube root of 3 and then times 9, 9, 9, 9, correct? Everybody, if you're doing this by hand without a calculator, 9 breaks down into 3 and 3, 3 and 3, 3 and 3, and 3 and 3. And we're pulling out groups of 3. Too many 3s here. 1, 2, 3, 1, 2, 3, 1, 2, 3. So this one came out evenly as well, correct? 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27.
Proud of everybody. That one, the test thing, is not as specific as that.
So when you print it,
I don't know.
oh, really?
Yeah.
That whole back page is to a different test.
No. Just how you would on a separate sheet.
Oh, it's to a different test. Oh, okay.
Which is a lot of the same stuff.
Right.
Maybe that's our retake. We had that level you just talked
Okay,
about.
thank you. No, I haven't. Okay, so looking at these two, when you multiply the same base, would I want to rewrite it as a radical? No, no, no. When you multiply the same base, what do you do with your exponents? Add them. So literally, I want you all to take your calculator right now. This is 4. You do not multiply the base. That's called double dipping. The base doesn't change. It's still base 4. 6/5 plus 1/2, math, enter, enter. That's all you gotta do. So add those up in your calculator, change it back to a fraction. 3/5? Is that what you said? And then that's all we gotta do. You just type in 6 divided by 5 plus 1 divided by 2, and then hit math, enter, enter. Did you all get 3/5? Okay, what did you get? 72 over 10. Okay, so maybe, sorry, 17 over 10. So now we're done. Now here's why we know we're done. Because when you start with rational exponents, your final answer can end with rational exponents. Everybody good with that? No, like I said, if you start with rational exponents, then you'll end with rational exponents. Do not write it as a radical. So we wouldn't need to simplify it more. Yes. Then we did it like this. See, the base wasn't the same, so we rewrote it as a radical. So look right here, the base is the same, correct? So we would, when you multiply, you add, correct, everybody? So that's base 2, it's still base 2, 1/3 plus 3/5, math, enter, enter. 14/5. Now understand, 15, 14 over 15. Okay, questions on that? Now, if those did simplify, your calculator would have done it for you, but let's say that you did it by hand or something and you got 4 over 2, that's 2, correct, everybody? You get what I'm saying? Okay, so now we're going to be to the section of the test that says solve for x. So we need to fly through this because I don't want to, we're cutting it close on time. So your first rule is isolate the radical, correct? So we would add 7, add 7. So we had 3 square roots of x equals 10, correct? What? I'm going to make this a 2. 2. So x. Okay, so we have 2 square roots of x equals 10, correct? My next step would be to divide by 2, yeah? You got to divide by 2 before you square it. Square root of x equals 5. Now we would square both sides, correct? Root cancels out with power, so x equals 25, yeah? You have got to check your answer, so you plug it back into the original. So we have 2 times the square root of 25 minus 7, does that equal 3? 2 times 5 is 10. 10 minus 7 equals 3. So 3 equals 3. So we keep the answer. Okay, next one will look like this. So the first thing is, first of all, don't we need to rewrite it as a radical? Is 4 under the radical? No. So we have 4 times the cube root, right, of x minus 3 to the 4th power, right, equals 64. Make sure you do it in the correct order. The first rule is isolate the radical. So we need to divide by 4 first, yeah? Okay, so we have the cube root of x minus 3 to the 4th power equals 16. Now what we do? Cube both sides. Root cancels out with power. So we have x minus 3. Will someone hurry and type that in for me? 16 to the 3rd power, hurry. 4,096. Okay, what would be my next step? 4th root both sides. Now look it, I'm solving and I'm taking an even root. Only when solving, not that I started out with an even root. I didn't start out with an even root, right? When I was going through and solving, didn't I just take a 4th root? So won't my answer come out plus and minus if I'm finding all of these solutions? Not just the primary solution, but all of the solutions. So root cancels out with power. We have x minus 3 equals, what's the fourth root? 8, so we get plus and minus 8. Even roots have plus and minus answers, correct, everybody? So then in this one, we still haven't solved for x. We would need to split it up. However, if x was alone, wouldn't we be done? X minus 3 equals 8. X minus 3 equals negative 8. And now solve for x. So we'd add 3, 8, 9, 10, 11. So x equals 11. We'd add 3. X is equal to negative 5, correct? Now we've got to check them. So everybody look back up here. If I plug in, I need you to hurry and help me out here. Type in 4 times the cube root, and then you're plugging in, this is 11. So 11 minus 3, you'll plug it in exactly as you see it. 11. Isn't that 8 to the 4th? That one works. Perfect. Let's try negative 5. So 4 times the cube root of negative 5 minus 3 to the 4th. I think they both work in this one.
Yeah.
Okay, awesome. So you'll check all your answers, because what if one of those didn't work? It'd be extraneous, right? Okay, next example, solve for x. So everybody watching, what do? Isolate the radical. Isn't the radical by itself already? Now we undo the radical. Wouldn't we square both sides? Don't have any parentheses. Root cancels out with power. So we have x squared minus 4 equals x minus 1 times x minus 1. We wouldn't break the forbidden rule. So we really have x squared minus 4 equals x squared. I'm distributing and combining like terms. Minus 2x plus 1. Now you'd say to yourself, it's a quadratic. Don't I need to solve by combining like terms and getting it set equal to 0? So we would subtract x squared. Oh, wait a minute. So we have negative 4 equals, aren't our x squareds gone in this example? So we have negative 2x plus 1. So am I solving a quadratic? No, it's linear. So don't we just solve for x now? So you subtract 1. So negative 5 equals negative 2x. And then we would solve for x by dividing by negative 2. So isn't x positive 5 halves? And then we would check it by plugging it back in. So if you check that one, will you check it real quick? I don't have my calculator out. You should all practice checking it anyways, because if you don't check it on the test, you will get it wrong. There are problems on the test with extraneous solutions. It works? Okay, it works. I'm telling you right now, if you don't at least find some extraneous solution, something you didn't check right. But you make sure you check them right, because I have people check them wrong and call something extraneous that isn't. You know what I mean? So you got to make sure you're checking them right. Right. If this one didn't work, since there's only one solution, we would say no solution. Everybody understand? Okay. Solve for x. So what would we do? We'd square both sides, correct? Root cancels out with power. Root cancels out with power. So we have 2x minus 1 equals 5x plus 5. Solve for x. So wouldn't we subtract 2x? We're trying to combine our x's. So negative 1 equals 3x plus 5. Then we would subtract 5. I always have people not know how to solve linear equations and I get confused. Negative 6 equals 3x. So x equals negative 2, correct? We would plug it in. That one does work as well. So all of my examples I made up happen to have all non-extraneous solutions. However, on the test, make sure you're checking. Okay, next thing is, given a formula for happiness, I'm just trying to prove a point here. If I give you any formula and give you everything to know except for one thing, can't you solve for that one thing using algebra? So everybody look. This is the equation for happiness. Happiness equals 1/2 times age times life squared 3 pi. So given that Miss Christensen is 25 and her happiness level is 100, what is life? So we're solving for life, correct? So watch. This is what I would do, is get life alone. So let's plug in what we know. Happiness is 100. So 100 equals 1/2. My age is 25. And then we have life squared. Can I just write L squared? And then 3 pi. So don't I really have, what you would do is type into your calculator 1/2 times 25. Isn't that 12.5? You do 12.5 times 3 pi. Isn't pi just a number? You type into your calculator 12.5 times 3 pi. And then we still have life squared. So now what would I do? Type that in. Right now, give me a decimal. 37.5 life squared. So I'm trying to get life alone. So when I divide by, oh, it's okay. Somebody else got it?
I got 1.2.
Okay, 117.75. So now wouldn't we divide by that? We're trying to get life alone, everybody watching. So we divide by 117.75, right? Now what would be my last step to get life alone? Square root both sides, correct? So you take the square root of whatever that is. Everybody good with that? Don't make those ones harder than they really are. Okay, next one, perform the operation. So find g minus f. So that's that minus that, correct? So parentheses, x squared minus 2x minus 3. This is the last part of the test. Minus x minus 3. We're not going to miss subtraction, so we're going to distribute -1 through. Negative x plus 3, yeah? Now we're just combining like terms. Do not multiply. X squared, any other x squareds? No. Negative 2x minus x is negative 3x. Negative 3 plus 3 is 0. Okay, domain is, it's a quadratic, so the domain is all real numbers, correct? Quadratics grow forever left and right. Okay, next one, g divided by f. So g is on top. X squared minus 2x minus 3. F is x minus 3. That's my answer, but does my answer simplify? So factor the top. What multiplies to be -3 adds up to be -2. 1 times 3, -3, right? The top factors to be x plus 1 and x minus 3. And on bottom we have x minus 3. Let's restrict our domain before we divide anything else. So our domain is all real numbers, but x cannot be 3. Now our final answer would be x plus 1. You got to restrict first though. Everybody understand? That's the level you're going to see on the test. Okay, next one on the test is find f of g of x or g of f of x. So everybody, isn't this one squish x back in with f, that's f of x. Squish it back in one more time, g of f of x, correct? So isn't this the one I'm substituting in? I'm really doing g of, what is f of x? X minus 3. So that's saying, what's my function g if I plug in x minus 3? So go to function g, plug in x minus 3. Does everybody understand? So wouldn't that be x minus 3 squared minus 2 times x minus 3? Are you all looking? Minus 3. And wouldn't I then need to rewrite it as x minus 3 times x minus 3? Double distribute, combine like terms, distribute in -2, correct everybody? So then we'd have minus 2x plus 6 minus 3. So this part I need to multiply out and then we'll combine like terms. Don't mess up on your algebra. Okay, let's do the other way. On the test, it's only going to be one or the other. You got to be able to do it right. So this one, squish x back in with g, that's g of x. Squish it back in one more time, f of g of x. So this is really the function, and what is g of x? That x squared minus 2x minus 3. So isn't this one saying, what's my function f if I plug in that? So this one would be the easy one, look. Instead of an x, we're plugging in that, correct? Does everybody see that you're going like this? So that would be x, parentheses, x squared minus 2x minus 3, minus 3. Now it's not multiplication, correct? It's combining like terms. So wouldn't this one simplify to be x squared minus 2x minus 6? And our domain would be all real numbers. And this one's going to come out quadratic, so it'll be all real numbers. Do you want me to keep simplifying that one? That's the last one on the test. We're good? You're sure? Okay, then that's it. That's everything.